Welcome to the Explainer. Okay, listen, we've got a really fascinating dynamic to look at today. I want you to picture two students sitting down for a Cambridge physics past paper, specifically syllabus code 0625. Let's call our first hypothetical student Alex. Now, Alex is a machine. Alex can cram in endless raw facts about gravitational fields. I mean, literally memorizing the entire textbook, but somehow still loses massive marks on the actual exam. Then you have student number 2, Sam. Sam is always rushing against the clock, completely missing the specific command word requirements of the question and ending up with answers that just miss the point entirely. So what is going on here? If you've got red pen marks all over your past papers, you know exactly how frustrating this is. It's a hugely common stumbling block. Today, we're going to fix it. We are charting a course through this exam strategy guide together to decode exactly what examiners are looking for when they use specific command words. We are navigating by the stars here, and by stars, I mean those key command words that dictate your entire response. We're going to master how to break down these tricky gravitational concepts and translate your raw physics knowledge into top marks.
So, here is our strategic roadmap for today. We're going to kick things off by unlocking the core theory behind gravitational fields. Then, we'll dive right into the procedural exam framework you need to structure your answers. After that, we are looking at some top examiner warnings straight from the source. And finally, we'll walk through a powerful sequence to deconstruct, solve, and evaluate your work. Let's get right into it.
Section 1. Unlocking gravitational fields. First things first, before we can even begin to analyze exam strategy, we absolutely have to establish our theoretical benchmarks.
Okay, it's actually really interesting how this entire, seemingly complex topic boils down to 3 core theoretical pillars. Honestly, whether you're taking 0625 or even 0651, 0652, 5054, or looking ahead to A-Level 9702, if you want to really grasp gravitational fields, these 3 principles right here are your foundation. Number 1, gravitational field strength depends heavily on the mass of the planet. It is not arbitrary. The more massive the celestial body, the stronger the pull at its surface. Think of the massive pull of Jupiter compared to what we experience here on Earth. Number 2, this field strength decreases as your distance from the planet increases. It's not just some constant magical field stretching out infinitely with the exact same power. No, the further away an object gets from that center of mass, the weaker that gravitational field strength becomes. And number 3, it is the gravitational attraction of our sun that actually keeps the planets in orbit. The sun's massively powerful gravitational field provides the exact centripetal force required to constantly change the direction of the planet's velocities, keeping them locked in that circular path. But here's the kicker, right? Understanding these concepts isn't just about memorizing these 3 bullet points on the screen. It is about being able to confidently explain the causal relationships behind them when the exam asks you why.
And honestly, that brings up the exact problem we see all the time: superficial breadth versus analytical depth. Remember Alex from earlier, the student who just memorizes disjointed facts? Well, Alex might see a question and state, gravity is a force and Jupiter has more of it. I mean, technically true, sure, but it's incredibly superficial. That's not what the command word is asking for. Now, top-tier candidates, the ones securing those top-grade boundaries, they approach this with analytical depth. They create cross-topic connections. They don't just say gravity pulls planets, they connect it directly to forces and motion, explaining how gravitational attraction results in a resultant force directed towards the center of an orbit. To get you to this top-tier level, I highly recommend using the PEEL framework. That stands for point, evidence, explanation, link. You make your specific point about the field, you provide evidence from the data given in the question, you provide the explanation of the underlying physics principle, and finally, you link it right back to the specific command word used in the prompt. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 2. The procedural exam framework. Now that we have the physics down, let's look at the actual technical methodology you need to deploy to secure every single one of those crucial method marks.
Look, knowing the physics is only half the battle. Earning those method marks comes down to a very precise 4-step sequence. First up, you have to extract the relevant data from the scenario. Don't just skim it like our friend Sam does, pull out the exact numbers you need. Second, you select your analytical framework. This means you actively decide which physics principles or formulas you actually need for this specific question. Third, and this is where so many students drop the ball, execute with clear notation. Write out the formula, show the substitution of the numbers, and display your rearrangement clearly on the page. Finally, step 4, present your answer with the absolute correct terminology. Imagine you had just 60 seconds to rewrite a flawed, messy answer. The transformation using these 4 steps is immediate. You'd extract the planet's mass, select the appropriate framework, let's say W equals mg, you'd execute the calculation clearly and present the final answer specifically as a force measured in newtons. Boom. Full marks.
What we are really talking about here is developing professional skills. You need to start acting like a working physicist, and that involves magnifying the details of the complex data provided to you on the exam paper. When you're faced with a complex chart or a dense data table showing how gravitational field strength drops off as you move away from a planet, you have to be able to scan that and quickly identify the core trend. Usually, the trend is quite clear. As distance increases, the field strength decreases at an accelerating rate. But you have to analyze that specific format, use the right terminology to describe what you've just found, and evaluate your own performance to make sure your conclusions actually match the physical evidence in front of you. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, Section 3, Top Examiner Warnings. Let's look straight at the data from the principal examiner reports to uncover exactly where candidates consistently throw away easy marks.
Every single year, examiners consistently identify 3 major, devastating mistakes when it comes to gravitational field questions. To understand why these warnings are so critical, consider a classic misconception that pops up all the time. A student might claim that a space station stays in orbit because there is no gravity in space. The examiner commentary on this specific flaw is always very, very clear. There absolutely is gravity in space at that orbital distance. In fact, that very gravitational attraction is what provides the centripetal force keeping the station in orbit in the first place. That fundamental, core misunderstanding of the physics is bad enough, but it is so often compounded by 3 very specific presentation pitfalls.
So, what are these traps you need to avoid? Pitfall number 1 is forgetting proper format. In physics, format doesn't just mean neat handwriting. It means explicitly writing the equation first, then showing the substitution of your values, and finally stating the final answer with the correct unit. If you skip steps, you lose method marks. Pitfall number 2 is failing to check presentation. You have to ask yourself, are my decimal points actually visible? Is my handwriting legible? Did I actually answer the specific question asked by the command word? And pitfall number 3, and I'd argue this is perhaps the most common one, is providing answers that are not specific to the given context. Listen, if the question gives you a scenario about a satellite orbiting Mars, your answer must specifically reference Mars and the data provided for Mars. A generic memorized paragraph about planetary orbits might be factually correct, but it won't get full credit because it ignores the context. You have to anchor your knowledge directly to the scenario in front of you. To really drive this home, the principal examiner reports actually give us a golden rule. I want to read this direct quote to you. Candidates consistently confuse key terminology. Always define terms before using them in extended responses. It is such a simple yet incredibly powerful piece of advice. You absolutely have to clearly distinguish between mass and weight, or between gravitational field strength and gravitational force. They are not interchangeable. If an extended response asks you to explain an orbit, start right off the bat by defining that the gravitational attraction is providing a centripetal force. Setting those definitions early signals immediately to the examiner that you aren't guessing. It proves you have a firm academic grasp on the terminology.
Section 4. Deconstruct, solve, and evaluate. Let's bring all of these strategies together into one concrete problem-solving framework that guarantees systematic processing.
Mastering this 5-step sequence is exactly how top-performing students process incredibly complex questions without panicking. Step 1, identify the given info. Step 2, break the problem into logical steps rather than trying to solve a massive multi-mark calculation all at once in your head. Step 3, solve systematically using the clear notation we talked about earlier. Step 4, check for reasonableness. Seriously, take a second and look at your answer. If you calculate the gravitational field strength of some tiny, newly discovered moon and your answer ends up being larger than the gravitational pull of Jupiter, you know immediately that you need to reevaluate your math. Step 5, justify any recommendations or conclusions based strictly on the data. Challenge yourself when you're practicing to mentally map out a structured Peel paragraph in just 30 seconds that checks off these exact steps. It completely ensures that every single minute you spend writing is directly aligned with demonstrating your true understanding to the examiner.
Now, to hit those highest-order assessment objectives, to get those absolute top marks, you need to go beyond basic problem solving.
You have to evaluate the quality of the evidence and the physics models themselves. Think deeply about idealized scenarios in a textbook versus reality. For instance, if a question simplifies an orbit to a perfect circle around the Earth, a truly strong analytical approach might explicitly note the limitation that real planetary orbits are actually slightly elliptical. Or if you're analyzing objects falling in a gravitational field, like the classic comparison of dropping a rock and a feather, you need to assess the assumptions being made. Are we assuming air resistance is completely zero? Stating these limitations and considering alternative interpretations is exactly what proves to the examiner that you don't just memorize formulas like our friend Alex, it proves you understand the physical reality behind the numbers and the boundaries of the theoretical models you are using.
So there it is. The entire system is laid out for you. We've seen how decoding those tricky command words, applying the right PEL frameworks, and evaluating physical models can fundamentally transform the quality of your exam answer. We've seen exactly how top-tier students build their responses step by step. The real question is, the next time you're faced with a blank exam page and the clock is ticking down, will you rely on just cramming disjointed facts, or will you use this precise framework to deconstruct, solve, and evaluate the physics? The choice is entirely yours, but navigating by these principles is the absolute proven way to chart a successful course. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.